In this lecture video, we are going to take a look at the chemical formulas and names of the ionic compound. Please read OER textbook chapter section 5.5, and the homework that associates with this is the Newton homework chapter 5.5. So the previous lecture videos, we look at different type of bonds. We look into how we determine the chemical formula by the experimental data, looking at the masses, and then we convert to the mole-to-mole ratio. In this video, what we are going to focus on is the general chemical formula that we can predict by using what we know on the periodic table, and we are going to use that to help us write the ionic compound. Okay, so in writing chemical formula of ionic compound would rely on the metal and non-metal, and the order that you are going to do or to write is have to be in this order. You need to write the metal first, followed by the non-metal, which is going to be the same order as the element that present on the periodic table, right? Because if you think about the periodic table, everything on the far left would be metal, everything on the far right would be non-metal. So that's why the order it will be this way. Okay, so metal and non-metal together, it would form ionic compound because, again, if we refer back into the previous video when we talk about the trends in the periodic table, we know that the metal has a bigger size, bigger atomic size than the non-metal, so they are most likely to lose electron, right? So therefore, it's going to lose electron to the non-metal, so non-metal would be the one that would accept the electron. So pretty much the metal will most likely to become cation, and non-metal would become the anion because non-metal is the one that accepting electrons. So we can also say that ionic compound would compose of cation and anion together. Okay. So in order to write the chemical formula of ionic compound, we need to determine the charges of cation and anion first, and we need to make sure that these two combine. When these two combine, it needs to give us the neutral compound. Okay, so that means we are looking at combine these two in order to give a neutral compound for ionic compound. What do I mean by neutral? Okay, so neutral means the overall charge, okay, have to equal to 0. Okay, so that means in this case the charge have to be balanced, right? So all the charges must be balanced. Okay, so it's all mean the same thing. For example, if you have negative from if you have positive from cation and negative from anion, these two, when you add them up, it have to be neutral. It have to be 0. Okay, so that's what I refer to as a neutral compound. Okay, so that means whenever that we talk about ionic compound, it have to always be neutral. You cannot have a charge at the end. Okay, so nature have everything in neutral. So that means we will need to refer back into the charges of the element on the periodic table in order to help us determine the charges of the cation and anion in ionic compounds. Okay, so pretty much what we're going to look at is we are going to take a look at how to assign the charges of these. Okay, so pretty much it's going to be it's going to fall back into the periodic table in chapter 4.3 that you learned earlier in the 4.3 video, that you are going to need to look at the periodic table, and pretty much what we are going to focus on would be the main group element. If you remember, the main group element refer to the S block, right? So this is S block, and also the P block as well. Okay, so so these two blocks would be the main group element. Oops, sorry, main. We can predict the charges of the main group element easily. However, the rest of these, you don't have to memorize their charges because they can have several type of charges. Okay, so pretty much in this case, the number of group that you know, according to the chapter 4 videos, we know that group 1 would contain 1 valence electron. So to lose electron, it would be easier to achieve the noble gas electron configuration, right? So that means pretty much group 1, right, it would be +1. Group 2 would be +2, right? And then we go all the way to group 3A, right? So this would be +3. And the chance of group 4 to lose or accept electron are equal. So most likely this group will not actually accept nor gains. Okay, so it's pretty much going to share. So pretty much this is the group that is going to most likely form covalent bond, not the ionic bond, or form covalent compound. So we can skip that. Okay, so the next thing we can skip to is group 5A. Okay, so group 5A is easier to accept 3 more electrons to achieve the noble gas electron configuration, right? So on the same as for oxygen group. And then for the last group, halogen group, would be -1, right? Because it's going to gain 1 electron. Okay, so pretty much if you have these together, right, they are going to, for example, if you have the pair between metal and non-metal together, the metal would most likely to lose electron to the non-metal, and the energy associated with that you already see from the previous lecture video as well in chapter 5.1. Okay, so if the metal is staying alone without having it to interact or react with the non-metal, is going to stay as the neutral atom, right? The neutral, most of these are neutral element, is going to lose again when it's actually have a pair to accept it, right? So something will not lose or gain electron if there is nothing to accept that electron, right? So pretty much if there is no if there is no non-metal, all of this metal will stay pretty much the same. Okay, so it's going to stay within the metallic bond where the electron will move around as a sea of electron. We already see this before. Okay, so pretty much what we are looking at is we are looking at the metal that is going to combine with the non-metal. We're going to take a look at what should be the chemical formula for that. Okay, so right now, I'm going to focus on only the main group element. Okay, we're going to talk about all of this group later. Okay, so let's take a look at magnesium. Because magnesium is in group 2, right, or 2A. Of course, the charge of magnesium, if it's become ions, if it's become part of the ionic compound, it would be 2+. Again, magnesium by itself will not have any charges, but within the ionic compound context, it would have 2+. Okay, so same thing with gallium would be 3+ because it's in group 3, right? Potassium would be +1, selenium would be -2, calcium would be -1. Now, wait a second, iron, silver, and zinc though, if you go back to the previous slide, okay, oops, sorry, you will see that iron, silver, and zinc, so these are right here. Okay, so iron, silver, and zinc. Why is it something that we have to predict here? Okay, so that's what we are going to take a look at. Okay, so pretty much the reason why I bring the transition metal into this ionic compound context is because they can have several charges. For example, when we talk about iron can have 2 forms, right? It's going to be iron 2+ or iron 3+. Right, so ferric or ferrous form, right? So that's the old name for it. So these iron 2+ and 3+ will behave differently in an environment. For example, your hemoglobin that carry the oxygen, right, would contain the iron, and the iron that is the active form to help carry oxygen would be the iron 2+, right, the reduced form for that. Okay, so that's why in order to tell the charges of these, you need to specify. We are going to talk about this later. Whenever we talk about the transition metal, you will always need to specify the charge. Okay, so this is transition metal. You will not know what they are unless you know something else and you can deduce for it. However, whenever that you talk about the main group element or the main group element, the charges are predictable. Okay, so these charges are predictable and you can predict them by the location on the periodic table. Okay, so the charge of transition metal can have several. Okay, so we're gonna take a look at how can we determine that later in this video. Okay, so pretty much this is a summary of it. Okay, so there are exceptions though. Whenever that you see silver and zinc, these two, even though they are part of the transition metal, these two actually contain only one type of charge. Okay, so silver would be +1 and zinc would be 2+. So therefore, when we talk about silver ion or zinc ion, we don't need to like specify whether it's +1 or +2 because it's assumed that it's always going to be +1, and in zinc for the ionic compound would be always +2, right? So this would be the exception of the transition metal that have only one type of charges, but everything else will have several form. Okay, so for example, titanium will be titanium 2, titanium 4, right? So chromium, that will be chromium 3 plus, chromium 6 plus, chromium 5 plus, and things like that, right? So the transition metal have several more type charges. Okay. All right, so pretty much this is what I would like to focus on right now. Okay, so pretty much what I want you to know is that the metal part that have only one specific charge that is predictable, right? So for example, in this case, it would be group 1A, 2A, and then the group 3A. Okay, so again, boron will exclude that because it's part of the metalloid. Okay, so and then another two, which is the exception, right? That we just talked about would be silver and zinc, right? Silver would be +1, zinc would be 2 plus, right? So group 1 would be +1, group 2 would be +2, and then group 3 would be +3. Okay, and for the non-metal, it would follow exactly what we talked about earlier, right? So pretty much for the non-metal, if you have those hydrogen content with all of this part right here, right, is going to with the negative, oh sorry, not group 4, this would be -3, -2, -1, right? And if hydrogen is combined with the metal, hydrogen have to have the charge of -1 also. Okay. All right, so when we write chemical formula of ionic compound, this is what you will need to do. Again, you always need to write the metal first, right? Because metal come first, right? All this metal come first before you write the non-metal. Okay, so that's going to be the order here too. You are going to write cation first, which is coming from metal. Okay, so cation, for example, 2 plus. If the cation has 2 positive charge, okay, you're going to combine this with the anion with this, which is 3 negative charge. Okay, so let's say that that's the Y. Okay, this is the X, so that way we can differentiate them, that they are different type of element. Okay, so metal and non-metal. So in order to balance this, you will need to make sure that ionic compound have to be neutral always, right? Remember, ionic compound always neutral, which means that the charges have to be, have to add up together to equal to 0. Right now, X, we have 2 plus, Y is 3 minus. In order to make these two charges to be equal, you need to find a common denominator. Okay, so 2 and 3, a common denominator is 6, right? So that means in this case, the charges of these two, in order for them to add up equal to 0, this has to be +6 somehow, and these have to be -6, right? Because if you add +6 and -6 together, you are going to get the overall equal to 0, right? So this is indicating the neutral compound. So how can we make X2 plus to have 6 plus? The answer is, well, all you need to do is you need 2 of them, right? That's what you need to do. Okay. Same thing for Y3 minus as well. In order to make it to be 6 minus, all you need to do is require. Oops, sorry, I did that incorrectly here. So let me rewrite this again. So to make X2 plus to be 6 plus, is need 3 more, right? So 3 times 2 equal to 6, right? And then for Y, you will need 2 more. 2 times -3 equal to -6. So this would be the general idea of how many you need. Okay, you are going to end up adding these two together. Okay, so when you add these two together, this is not the chemical formula yet because they are not neutral yet, right? You still have separate charges, you still have separate positive and separate negative. So the correct chemical formula of this, okay, can actually be written in this form. Okay, so because we need 3 of X, this number 3 right here, or 3 ions of X, need to become the subscript. So pretty much you can write as X subscript 3. The subscript tell you how many X you need in a chemical compound. Okay, so we need 3 of them. And you need 2 of Y, therefore for Y you would have to have subscript 2 that come with it. Okay, sorry, let me. Okay, so again, the subscript tell you about the number of atom of that element within the compound. And because these are already neutral, right, because you have each X is +2, 3 of them is +6, each y is -3, two of them is -6, overall equal to 0. Therefore, you don't need to indicate any charges on this molecule because this is already neutral. So again, ignore all of those charges once you already balance the number of subscript. Okay, so you should not write any more charges because already balanced. Okay, so this would be how you write the chemical formula for ionic compound. Okay, so you write the cation first, followed by anion, metal, followed by non-metal, and make sure that the number of elements will need to come out to give you the overall 0 charge. Now let's take a look at example 3. Example 3 gives you pairs of metal and non-metal, asking you to write the chemical formula of the ionic compound. Okay, so pretty much you will need to know first, right, what are the charges of all of these elements, so that way you know exactly how to pair them up, right, how many of them we need per chemical formula. So I'm just going to go ahead, start with 3A. Okay, so sodium, if you look up, sodium is in group 1A, so therefore sodium would have the charge of +1. So again, the charge will be written on the top right corner, right, as a superscript. And oxygen is in group 6A, so oxygen contain 2 negative charge when they both are paired together. Oops, sorry. So again, if they are stay alone, they will not giving electron or accept electron, but when they pair together, one is going to give off electron and the other is going to accept, right? So according to the energy diagram that you already see in the previous video. Okay, so in this case, you will see that for every one sodium, right, every sodium, you have 2 negative of the oxygen. So if you're looking at the charges here, you are not going to be able to combine them yet because we have only 1 plus, you have 2 minus here. If you add them, the overall would be -1. But again, remember the ionic compound have to always be neutral, which means the overall have to have 0 charge. Therefore, in this case, in order for this compound to form, it's going to require 2 of the sodium. Okay, so it's going to require 2 of sodium per 1 of the oxygen, right? Because 2 of the sodium, each sodium is +1, therefore these charges would be +2, right? And we know that from oxygen is already -2, so overall add together is going to equal to 0. Therefore, in this case, this is the combination that we are going to combine. So this is not the ionic compound chemical formula. The ionic compound chemical formula have to come out to be neutral like this, right? So that means in this case, in order to make that to be neutral, you will need 2 of the sodium in the molecule. In order to write that, it would be sodium, okay, and then subscript 2, okay. And then since oxygen we require just 1, you are going to indicate oxygen with just 1. You don't need to write any number 1 as the subscript here because it's already implied. Without this number 1 right here, it's already implied that we need 1 of this oxygen. Okay, so this would be the chemical formula of sodium oxide right here. Okay, so I would like you to start working on 3B, 3C, and 3D. Use the periodic table to do this. Please start doing this and pause the video now and then resume it again when you finish. All right, let's take a look at your finished work. Okay, so if you have not done yet or have not finished yet, please again pause the video and resume when you finish. So calcium, okay, so calcium is 2 plus because in group 2A. Nitrogen is in group 5A. Nitrogen contain 3 minus. Okay, so obviously these two, if you add them up, you are not going to have a 0 charge overall. So in order to figure this out, you have 2 plus and 3 plus, so you're going to find common denominator. So somehow the common denominator would be 6, so somehow you need to have 6 plus for calcium, and you need to have 6 minus for nitrogen. Therefore, it's going to require, right, so 3 of oxygen per 2 of the nitrogen, right? So that way 3 of the calcium, 2 plus, add up together would be 6 plus, right? So what do we mean by that when I talk about like, so if I want to list out 3 calcium plus, is refer as you literally have like calcium 3 of them, right? So you have calcium 3 of them like this. So therefore, when you add the charges together, that's why it come out equal to 6. Okay, so same thing for nitrogen as well. Okay, so I'm gonna erase this. Okay. So therefore, in this case, in order to write out chemical formula of this, you will need 3 of the calcium and 2 of nitrogen. Therefore, the chemical formula would be calcium subscript 3 and nitrogen subscript 2. Okay, so this would be the chemical formula of the compound coming from calcium combined with nitrogen. Okay, so sometimes the easiest way that people do is to do the exchange of the charges and exclude the sign. For example, some people might swap these charges, right? So swap the charges, so number of the charge to be on the other side of the other element. So number of this to be on the other side of the other element, right? So that's why in this case, sodium got 2. I don't recommend doing that. If you want to, just make sure that you reduce everything. Okay, so one thing to note, the ionic compound chemical formula need to be in the smallest ratio. Okay, always. The reason for that is because the ionic compound, if you recall from the previous lecture video, they are in form of crystallized structure. We don't know the boundary of them. We don't see them as an actual molecule. They are a lattice that alternate between cation and anion. So to represent them correctly, we need to represent them in the smallest ratio, which what we call formula unit, right? So from the previous video, we talked about all of that already. Okay, so let's take a look at C. Okay, so part C would be magnesium, right? So in group 2 would be 2 plus. Bromine, group 7A would be 1 minus. So obviously in this case where you have 2 plus and 1 minus, of course you're going to require 2 of the bromine. Therefore, the correct chemical formula of this would be magnesium bromide subscript 2. Okay. Now, what about aluminum sulfide? Okay, so same thing here. Aluminum is in group 3A, so aluminum would be 3 plus. Sulfur would be 2 minus because it's in the same group as oxygen, right? So again, so 3 plus, 2 plus, you are finding the common denominator. So you will need 2 of aluminum per 3 of the sulfur to have the overall charge add up together to equal to 0. Okay, so in this case, the chemical formula of this would equal to aluminum subscript 2 and then sulfur subscript 3. Oops, let me use the same color here. Okay, so that would be the answer for this. So again, how people do it sometimes is the exchange of these charges, but I don't recommend doing this, and I will tell you. Okay, so an example that, for example, if you want to write, right, so you can actually put this down here and put this down here, but ignore the sign, right? So that means in this case, you are going to end up with X subscript 3 and Y subscript 2. This part right here with the exchange of the charges that swap the place to the subscript only work when you already have smallest ratio. It will not work, for example, if you have something like this. Okay, so if you have something like a combination between, let's say, if you have a combination between calcium 2 plus and oxygen 2 minus, this is already 1-to-1 ratio. So the correct chemical formula of this would be just calcium oxygen like that, right? So this would be the correct chemical formula. If you do the chart swap, right? So if you actually going to swap this, like let's say put 2 below oxygen and 2 below calcium here, you need to make sure that you are going to need to get into the smallest ratio. Okay, so the reason for that is because, again, the ionic compound must be represented by the smallest ratio as the chemical formula. So this one is not correct. You need to reduce this ratio in order to get the smallest ratio between the two elements. Here are more practice of how to write the chemical formula of any compound when you are given the ions, different ions, right? So again, when you are going to write it, you need to write the cation first before the anion. You might ask me, wait a second, so I know that the cation here are metal, right? But this one is not metal, it's all non-metal, right? So the nitrogen and hydrogen, these two are non-metal. So how come that we consider this to be ionic compound? So I just want to point out that the ammonium is one of the polyatomic ion. That is the cation. It's the only polyatomic cation that we are going to see in this term, which mean poly mean many, atomic mean atom, right? It's the ion that contain many atoms, so that's what it is. Because this type of polyatomic ion is a positive charge, so that means in this case, even though you have the nonmetal and nonmetal that you are going to combine with all these nonmetal, the overall compound is still going to be considered as ionic compound, because ionic compound come from cation and anion. Okay, so this would be one of the exceptions. One of the you will see this one as the exception. Okay, so whenever that you see ammonium, this is called ammonium ions, which I'm going to go over the list later. You need to know that that's going to be the exception for the ionic compound, that it can contain all the nonmetal for that. Okay. So now again, right, so in order to write this, you will need to write the cation first, okay, followed by the anion. So since 1 to 1, right, 1 plus, 1 minus, therefore it's going to be just 1 to 1. You will just require one of these per one of this. Right, so same thing for barium as well. So barium 2 plus, how many bromine do we require? It's going to be 2 of them, right? Because this is 2 plus, this is 1 minus. Overall, you need 2 of these in order to balance this 2 plus. Okay, so similar to what I went over earlier, right? So the overall charges between cation and anion add up together have to equal to 0, right? So if this is 2 plus, right, this contain 2 of them, but each bromide is -1, right? Come from that. The overall will equal to 0, so that's what we are looking for. Okay, so it have to be neutral. Okay, now with aluminum bromide, it would be you are going to require 3 bromide per aluminum, right? 3 this 3 plus. Same thing for manganese, right? So it's going to be 3 bromide ions. Okay, so what I'm going to do is I would like you to pause the video now and complete those assign block that I have for you. Okay, so I would like you to think about what you should write and also write it out. It doesn't matter if it's wrong, it's fine, right? Because you're gonna check your answer anyways, but I want you to try it yourself first. Okay, so let's pause the video and resume it again when you finish. All right, let's take a look at your answer. Okay, so again, if you have not finished, just don't watch the next part of this. Okay, so let's complete it first. All right, so let's take a look at the first one. Okay, so we have ammonium 1 plus, nitrogen 3 minus. So what do we need in order to make it to be balanced? The answer is we need 3 of these, right? So in order to specify 3 of these, okay, what you need to do is you will need to use parentheses. Okay, so never ever change subscript. Okay, so some of you, if you have this written out as, let's say, NH 4,3 like this and N, it's not the same thing. Remember, you are changing the subscript, you're changing the identical, right? So remember the joke that I mentioned earlier, like in the beginning of the term or something, about the guy went to the bar with his friends, right? He ordered H2O. The bartender asked his friend, what do you want? And his friend said, I would like H2O too. And that his friend just end up dying just by drinking H2O2, right? Because these are not the same. Okay, so as you change the subscript, you are changing the identity of the compound. Again, if you change the number of subscript, you are changing the identity of the compound. Okay, so that means in this case, this is incorrect. Okay, so you need to use parentheses. Okay, so the next thing you might ask me, okay, yeah, I know that. Okay, so I'm going to use parentheses, but is it okay if I multiply it in? Okay, so let me explain that to you. For example, is it okay? Yeah, I have parentheses of this. I know that I need 3 of this, right? So that's why I have superscript after the after parentheses. And you might ask me, is it okay if I multiply this n, okay, and then have it as N3H12N, like that? The answer is no. Again, because if you do this, you are changing the two different compound. Now, this is NH4. This is no longer NH4. It's N3H12. Is something else. It's completely not the same thing. Okay, so it's similar to water and hydrogen peroxide example earlier, right? So that means never ever multiply the number, the subscript, into the parentheses. The parentheses have to contain the group that come together as a bundle, right? So all of these that come as a bundle, you need to treat them as a bundle. You cannot separate them, you cannot break them apart, and you cannot change that subscript. you cannot change this number of nitrogen to 3, 4, 5. You cannot change this hydrogen to, you know, like 1, 2, 3, 4, 5, whatever. It have to stay as it is, as a bundle, as a group of that atoms. Okay, so you cannot change that. Therefore, in this case, to best represent the ionic compound chemical formula of ammonium nitride right now that we're having, so you are going to need 3 of these, right? So that's why I use parentheses of this group is come as a bundle, right? And because we want 3 of this group, that's why the number 3 would be outside the parentheses as the subscript. Okay, so if you're looking at the next one, okay, so you can check your answer for the next one. Same thing for these two, right? So you have barium 2 plus. This whole thing come together as a bundle. Okay, so the thing that tell us about the charges is going to be the superscript, which means this one right here, 2 negative tell us about charges, okay, or the charge of that, right? So the subscript tell us about the charge of the ions, and the subscript that you see here is tell you that in these ions, right, is contain 3 oxygen. Okay, so that's all it tell us. So never change this number of the subscript, because subscript it would change your identity. Okay, so that means in this case what you are going to look at is you are going to look into, let me erase this for a second. Okay, so what you are going to look at is you are going to look into how can we make these charges to add up equal to 0. Obviously it's already positive 2, this is negative 2, so it just require 1 to 1. So that's why your answer come out to be every one barium will require 1 of the CO3. Okay, so CO3 bundle. So this one is called carbonate ion. Okay, so we're gonna talk about that later, about the name of this. Okay, I hope that makes sense. So now same thing for the next one. Okay, so the next one is this NH4 plus with PO3 minus. You will see that we have 1 plus, we have 3 minus here. So therefore we need 3 of these per 1 of this group. So that's why you end up with 3 of this group, right? And then you are going to have what? Just 1 of PO4, right? So 1 of PO4. Again, you do not have to include the charge anymore, because the charge, since already balanced, the overall chemical formula of the ionic compound have to be neutral, which indicate by there is nothing above it, right? There is nothing as the superscript written as the charges. Okay, so same thing for the next one, barium 2 plus, phosphate 3 minus. Okay, so we need 2 of these, we need 3 of these. So therefore, if we need 3 of these, you are going to write as subscript, right? If you need 2 of these PO4, right, because there are 3 negative charge here, then you will need to use parentheses to will not change the PO4. You are going to change only how many we want, which is going to be outside the parentheses. Okay, so we need 2 of the PO4. Okay, for the next one, this is 3 plus, this is 3 minus, so it's 1 to 1. So we can just write AlPO4. This is 4, this is 3. So the common denominator would be what? 3 and 4. The common denominator would be 12, right? So in this case, if I write this as PO4 3 minus, okay, and the other one is Mn4 plus, to make this to be positive 12, because that's the common denominator, and to make this to be negative 12, what you need is you will need 3 of these and you need 4 of this, right? So that's why at the end we will have subscript for manganese 3 plus and subscript for 4 of the phosphate. The reason for that is because eventually when you add up all of these charges, it need to come out equal to 0. Okay, last one is the same thing. Okay, so it just add more stuff to it, but what you're gonna do is you're gonna treat this whole thing as a bundle. Doesn't matter how many atoms you have, just treat them as a bundle that you will never change. All you need to do is just write parentheses over it, right, when you actually write chemical formula. Okay, so in this case you are going to require, if you look at the charges of this, right, so we have negative 1. Okay, this is positive 3. So therefore in this case, negative 1, positive 3, you will need 3 of these, right, to add up to positive 3 to be neutral. So that means in this case, so in this case, you are going to need 3 of these. So let's write a subscript on that. Okay, so next thing I would like you to do is that you are going to, as you already see all of these, I would like you to go ahead, complete number 4. Okay, so of these DIY right here, okay, the answer will be posted on Moodle. Okay, so complete all of those is going to help you practice this more. Again, you are going to write cation first, followed by anion, metal, followed by non-metal. Okay, so that's going to be your practice. Don't forget to check your answer against the key on Moodle. The group of the ions that contain many atoms, or what we call polyatomic ions, is listed on this lecture manual page 84 here. Okay, so the most common one that you are going to use often in the future exam and also in the next series of the chemistry as well would be the one that I block in red. Okay, so those are the one that you are going to be used the most. On the exam for this course, this whole page right here, this whole list would be provided for you. All you need to do is you need to know how to use them. Okay, so both chemical formula and also name would be given. You just need to know how to use them and also how to use the name for from them. Okay, so pretty much what we are going to take a look at is one thing I want you to circle is that ammonium is the only cation that is part of the polyatomic ions. If you look at everything else, those are all the anion, right? So pretty much of the, most of the majority of the polyatomic ions are anion. The only positive cation would be ammonium. That's it. Okay, so that means in this case, if you have ammonium paired up with any of these or with any of the non-metal ions, is going to still consider to be ionic compound. Okay, because this is the cation. Okay, so it's going to make ionic compound. All right, so why do I mention about this? Okay, so pretty much you are not going to have to deal with only the anion on the periodic table, like for example, fluorine, chlorine, bromine, oxygen, and things like that, right? You are going to see more example that paired up with of these polyatomic ions as well. And the ionic compound that come from these polyatomic ions is used in chemical household, like many of them, right? For example, sodium hydrogen carbonate, right? Or sodium bicarbonate, for example, right? That as the baking soda, right? We use that, right? So we use sodium hydroxide as, you know, like cleaner, right? A pipe cleaner and things like that. So that means these are the common one that we are going to see. So that's why we are going to use this a lot, and we are going to see more example in the next series of the chemistry as well. Okay, so we already see how to write the chemical formula of the ionic compound. The next thing that you are going to look at is you will need to look at how to name ionic compounds. Okay, so this slide right here is going to be part of the additional handout 5.5, which is going to be toward the end of your lecture manual. Okay, so if you go all the way back to the end, you are going to see the slide that listed as how to name ionic compound. Okay, so pretty much in order to name ionic compound, there will be a system that you will need to follow. One is when you see ionic compound that contain only 2 elements. Okay, so binary mean 2, right? Bi mean 2. So these type of compound contain only 2 type of the element within the compound, metal and non-metal. Okay, and these metal have to have predictable charge, which means it's going to be the charge from the main group element. I'm going to elaborate more of this in just a few minutes here. So for example, what do we mean by one specific charge? It would be this, right? It would be coming from this group right here that we can predict. Okay, group 1A, 2A, and 3A, and silver and zinc. Okay, everything else, the metal will not be predictable. What I'm looking at right now is the one specific chart for metal. Okay, so that's what we're gonna take a look at. Okay, so the second type would be the binary ionic compound. Again, bi, right? So it means 2 elements. Okay, if you have more than 2 elements, it will not call binary ionic compound. This type of ionic compound would contain only 2 elements. Okay, so the second type is going to be a little bit different from the first type. First type is what we know exactly what their charges are based on the location on the periodic table, right? The charge of the metal. However, the second type, we don't know what their charges are because they can have multiple charges. Example of that, what I talked about earlier would be iron, right? So iron can be iron with a 2 plus or iron 3 plus, right? So we already talked about that. So in this case, these type of metal that are not the main group element, which is part of the transition metal, and also lactanide and actinide, these are going to be the metal that can have several type of charges. You don't need to memorize their charges. What you need to know is how to deduce to get that charges. The reason why we are going to name them differently because we need to specify the charges because different state they would react differently, right, in the environment. Okay, so that's why we need to specify them. The third one is the non-binary ionic compound. Non-binary mean not two, right? Not just two elements. You are going to contain. You're going to have more elements. So those that contain more elements would come from the polyatomic ions. Okay. And which are these, right? Because contain, so you have, for example, if you have chlorine and oxygen in part of the anion, if you add this to another element, which is the metal, right? So you're gonna have more than two type of elements. So that's why we call non-binary ionic compound. Okay. So how the last one is you are going to look at those ionic compounds that have water molecule attached to them, or what we call hydrated ionic compound. Okay, so hydrated ionic compound, which mean that the compound that already like absorb water molecule, right? So if the opposite of hydrated ionic compound would be anhydrous. Okay, anhydrous mean is completely dry without any molecule of water in ionic compound at all. Okay, so most of the time if you purchase the anhydrous form, it's going to be more expensive because everything when it's exposed to air is going to expose to moisture as well. So most of the time ionic compound would come with together with hydrated form. To make it super dry or non-hydrate form or anhydrous form is going to require process for that. So that's why the price of the anhydrous is always more expensive than the hydrate form of ionic compound. Okay, so you're going to see more of these when we get into the lab, okay, in Chem 122 and 123. All right, so what we're going to do is I'm going to start one type at a time, okay, so because these, how you name them would be slightly different, okay, so we need to actually differentiate them, okay. So I'm going to start with the first one. For the binary compound that contain two type of elements, you are going to name the metal first. Okay, so similar to writing chemical formula, you always start with metal. So same thing here. You are going to name the metal first, then followed by, so you're going to name this metal. Then you're going to follow by non-metal. Okay, the name of this metal would be exactly what is written on the periodic table. For example, if it's Li, it would be lithium. If it's Mg, it would be magnesium, right? If it's Ga, it would be gallium. So the name of the metal would stay as it is. Okay, you will not change anything for the name of the metal. For the name of the non-metal though, so this name of the non-metal, so which are right here, right, including hydrogen right here. If you have metal that combine with any of these non-metal, you are going to name the non-metal and change the name and then eventually gonna ending with "ide." For example, fluorine would become fluoride. Chlorine would be chloride. Bromine would be bromide. Iodine would be iodide. Oxygen would be oxide. Sulfur would be sulfide. Selenium would be selenide, right? Phosphorus would be phosphide. Nitrogen would be nitride. Carbon would be carbide. Hydrogen would be hydride, for example. Another common one that is come from the metalloid would be arsenic, right? So arsenic can be arsenide. So that's how you change the name of the non-metal. So pretty much you are going to change and then end with I. Okay, so that's pretty much what we're gonna do. And here are example of the list of what I just mentioned earlier. Okay, and you don't. That's it. You don't have to do anything else. Name metal the same. Change the non-metal ending and then ending with I, right? So change a little bit of their name and then ending with I. So for example, if you have CaCl2, the name of this would be calcium, right, come from the metal first. Ca is calcium. Chlorine, this is chlorine. You are going to change that to chloride. So the name of this would be calcium chloride, used in de-icing the road, right? So the next one, right, so you have magnesium and nitrogen. You are going to name magnesium as it is because that's the name of metal. The only thing you're going to change is the name of the non-metal. Okay, so you're going to change from nitrogen to nitride. Okay, so it would be nitride. Okay. And for binary ionic compound with multiple charges, okay, so this would be slightly different. So remember the first one we talked about, the metal have to be in the main group element. Okay, so for example, group 1A, 2A, right, 3A. So that would be the main group element for the metal. Now, with the second system, which is the binary ionic compound that contain multiple charges, so this one, the metal, okay, going to come from the transition metal or the lactanide and actinide group, right, the last two, the F block group. Okay, so the reason for that is because these can contain many charges. Therefore, we will need to specify their charges because they contain multiple type of charges, so we need to specify them. For example, if I'm talking about iron 2 plus versus iron 3 plus, right? So for example, iron like that versus iron like this, which form am I talking about? I need to be able to specify that, right? So in order to specify the difference between these two, you need to name them differently because these two, clearly the ratio are not the same. So they are not the same type of compound, right? They're not the same compound because they have different the charge of the iron. So therefore, in this case, to name each of these, you need to specify what charges are we talking about. So that way we know exactly what type of chemical formula that we are looking at, right? So in this case, the metal that we are talking about here that have several charges can be exactly what is highlighted in green. Okay, so all of these are the one that we will need to specify their charges. Okay, and how to specify the charges of the metal? You are going to use Roman numeral number. Okay, so here are the list of Roman numeral. Okay, so +1 would be just that 1 right there, all the way to +8, right? And you are going to follow by the name of the non-metal. Okay, so these Roman numeral number tell you about the charge of the metal. Okay, the name of the non-metal will still be the same as the first system, which is you're gonna ending non-metal with "ide." Right. So for example, fluorine, fluoride, bromine, bromide, right? Chloride, hydride, carbide, oxide, nitride, phosphide, and things like that. Okay, so the only difference that you are going to see is that you are going to increase one more step. Everything stays the same except for the transition metal, you need to specify their Roman numerals. Okay. For example, okay, so if you have this, exactly what I mentioned earlier, right? So how do you know which iron this is? So you need to specify the charge. Okay, so, sorry. How do we determine the charge of this transition metal if we don't have to memorize them? In order to do it, you will need to start from what you know. Okay, the species that we know is the charge of oxygen. Okay, so we know that 3 oxygen that we have, each oxygen we know that is on group 6A. So each oxygen contain -2 minus. Sorry, -2, right? And we don't know what is iron, but we have 2 of them. Okay, we don't know what iron is, so I'm just gonna write out as iron. Okay, so these 2 add together because it's neutral. That's why you don't see any overall charges here. It's indicate that at the end when you add this, it have to come out equal to 0. So that means all you need to solve is the algebra right now, right? So what you have is what, like, move this to the other side, become +6, right? So you have 2 iron equal to 6, right? So pretty much move this 3 times -2, -6, move to the other side is +6. Then you're going to divide both sides by 2, right? To get rid of that 2. So that means in this case, the iron, each iron that we are talking about is going to have the charge of +3. That's how I know it. Okay, so that means in this case, we are going to specify the charge of iron equal to +3. How do we do that? Okay, so in this case, what you're gonna do is you're gonna use that +3 that we determine and write as Roman numeral that is equal to 3. Okay, so this is going to be in this Roman numeral right here is going to indicate the charge of the iron. So it tells us that, oh, this ionic compound that contain iron is contain iron 3 plus. That's what it tells us, right? So that's what the +3 or the 3 Roman numeral tell us. Okay, so pretty much if you follow this, the name of the metal, which is iron, followed by the Roman numeral that indicate the charge of the iron. And then the next thing is to follow or to ending with the non-metal name with "ide," right? So in this case would be oxygen, you are going to end with oxide, for example. Okay, so let's take a look at the next one. Okay, so next one, titanium, oxygen. Okay, so what should be the correct answer for this, right? So pretty much the name would be titanium, right? So that's the name of the metal. The second thing you need to specify is the charge of the metal, because titanium is part of transition metal. It's not the main group element like the first system. So in this case, we need to specify charge of titanium. In order to do that, again, you are going to do the same thing. We have 2 oxygen. Each oxygen is -2. We're going to add that to titanium, right? Because we don't know what that is. And this come out should equal to 0, right? Because everything add up have to equal to 0. That's how we find out the balance overall ionic compound chemical formula. So if you do this, so for this, you are going to see that the titanium in this case going to come out to have 4 positive charge. Okay, so this +4 right here is going to be part of the Roman numeral. Okay, so that would be that would be 4. Okay, and you're gonna end with oxygen. You're gonna change that to oxide, right? So that would be the name for it. Okay. All right, so the next thing we're going to look at is the non-binary ionic compound, which means that it's the ionic compound that contain more than 2 types of elements. Okay, so these are the one that contain polyatomic ions. Okay, so for example, the name for these, what you're going to read is going to be cation, then followed by anion. Okay, so if you have anion as polyatomic ions or the cation as polyatomic ions, you do not have to change their name. What do I mean by that? Okay, so if you go back here, if you see any of these group of elements come together in your chemical formula, you don't need to change their name. You are going to read them as they are. For example, this one would be ammonium, this one would be acetate, this one would be nitrate, and so on. Okay, so for example, if you have this, right, so the name would be NH4, that would be ammonium, right? The name would be as it is. That's ammonium right there. And then you're going to follow by the group that contain NO3. So NO3 would be nitrate, right? So in this case, it would be ammonium nitrate. For cation that come from metal, such as sodium and cadmium, this is when you will need to follow the previous 2 steps that we talked about earlier. Sodium is part of the main group element. You don't need to specify the charge. Therefore, the name for this would be just sodium and then followed by nitrate. Okay. Cadmium is part of the transition metal, which we need to specify the charges because cadmium can have several charges because it's part of the transition metal. So in this case, how do we know what is the charge of metal? You will need to rely on something that you know, right? So if you look up, if you look up the nitrate NO3, you see that the nitrate contain a -1 charge. Okay, so that's how I know. Okay, so that means in this case, because nitrate has -1 charge, we have one of them. Therefore, clearly, we know that the cadmium here have to be +1, right? Because +1 minus 1 is equal to 0. So that means in this case, the Roman numeral that specified the charge of cadmium would be 1. Okay, so that means the name would be cadmium 1 followed by nitrate. Okay. All right, what about if I have something like this? What if I have NH4Br? Okay, so what should be the name of this? Still going to be the same, right? When you see polyatomic ions, you're going to name that as it is. So this would be ammonium. Okay, so this one would be ammonium. Okay. And the last one, this is not polyatomic ion, because if you're looking at it, this is come as a group, right? This is come as another part of it. So again, this is non-metal, right? So it's going to follow the previous two steps that we talked about later before. Whenever you see non-metal, you change that to ide, right? So this one, instead of calling bromine, is going to be bromide. Right, so that's the name of it, right? So you name polyatomic ion the same, and then ending, if the ending with the non-metal, then you change the non-metal to ending with ide. All right, so the last part of this naming is hydrate ionic compound, which means that ionic compound that contain water. The name of hydrate ionic compound would be the same as the previous three systems that we talked about earlier. Everything will be the same. You need to name the organic compound exactly the same as that. The only thing that we need to add into this, right, so similar to like making cake, right, you keep adding more layers to it. The layers that we're going to add to this is to specify the number of water that is going to be part of the molecule. Okay, so in order to specify the number of water, we are going to use the prefix. Okay, the number prefix will tell you about the number of water. And the word water, we're going to use the word hydrate instead. So pretty much you're going to use this dot right here to separate the ionic compound from the water molecule that attached to it. Okay, so what do we mean by that? Okay, so these are the prefixes that you will need to know. Okay, so these prefixes will be given on the exam. But if you are familiar with this, later on in chemistry series, it's going to make your life easier, right? So pretty much mono mean 1, di mean 2, tri mean 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. Okay, so the how many water it is, you are going to specify by those prefixes. Okay, for example, okay, so Ba is in the main group element. Therefore, the name of this would be barium. You don't need to specify the charge because it's in main group element. Nitrogen is the only one nitrogen. It doesn't have any other, right? So this is part of the binary ionic compound because it contains only 2 elements, right? So that means in this case going to be barium. Nitrogen, we are going to, because it's non-metal, we're going to change that to end with I, right? So nitrogen would be nitride. So the name of this would be barium nitride. And to specify the number of water, you are going to look at how many water in this molecule. So there are 5 of them. So what is the prefix for 5? Prefix for 5 is penta, right? So that means in this case it's going to be penta. Water would be hydrate, right? So water would be hydrate. So it's going to be pentahydrate. Pentahydrate tell you that there are 5 molecules of water. Hydrate is water, right? So pretty much the same that we see earlier. All right, so what I would like to do is I'm going to walk you through this, and then I'm going to let you complete the next example. Note that on the exam, my expectation is for you to be able to do both. First, to be able to read the chemical formula into name, right? Write the name for that. And second is do the reverse process of it, which means that you are going to be able to read the name and then provide me with the chemical formula. Okay, so you need to be able to go in both ways. The first one, potassium, right? And then iodine right now. Okay, so we have only 2 elements. This is also 2 elements. This is also 2 elements. So what we have right now is the binary ionic compound. And look at the metal. Okay, so this is main group element, this is main group element, this is also main group element. So which means that what you're going to do is you don't need to specify any Roman numeral. It's just going to be as it is, right? Potassium iodide. Second one would be strontium chloride. Wait a second. Is this correct chemical formula though? How do you know? Okay, so again, in order to check that, you will need to know the location of each of these elements, right? Strontium is in group 2. So it's going to have 2 plus. Chlorine is in group 7A, so it's going to have 1 minus. So therefore, in this case, you see that 2 plus 1 minus, to make them balance, you need to have 2 of the chloride. Therefore, you will need subscript 2 after the chlorine. Okay, so this would be the correct chemical formula for it. The next one, you're gonna, again, so this is part of the main group element for metal. So the name would be the same, calcium, and then nitrogen would be nitride. Okay. All right, number 6. So again, my question is, what are these parentheses tell you, right? What are those Roman numeral in the parentheses tell you? Again, it tell you about the charge of the metal. So again, let me refer this. So these tell you about the charge of this. Okay, so these tell you about the charge of this. So that means if you know that, it's going to help you to be able to write out chemical formula easier. Okay, so that means in this case, tin to oxide, right? So tin, if you look at the chemical formula, it would be SN. And we already determined that the 2 inside this parenthesis is referred to the charge of tin. So that means tin 2, it would be tin 2 plus. Oxide come from oxygen. Okay, oxygen is in group 6A, so oxygen would have 2 minus. So if you're looking at this ratio, it would be 1 to 1, right? Because 2 plus 2 minus add together would be 0. So the chemical formula of this would be SNO. Okay. Now, second one. Okay, so we have Hg, mercury, and Br is bromine. Mercury is part of transition metal. Therefore, you will need to use Roman numeral to specify its charge. Okay, so think about this. We have bromine. We have 2 of them. Okay, we have 2 bromine. Each bromine is going to have the negative 1 charge because bromine is in group 7A, right? So bromine is, is have 1 negative charge. But because we have 2 of them, right? So that's why I include 2 right there. Okay, so therefore, total would be negative 2. So you are having this, and you're going to add up to the charge of the Hg, right, mercury, which we don't know. But we know for sure that the overall, right, this element right here, overall is equal to 0. So that means all you need to do is solve for that, right? So multiply these together and move to the other side. You are going to get the charge of mercury, in this case, equal to positive 2. Okay, so that means the Roman numeral that you need to use in this number 6b is going to be parentheses 2 Roman numeral. Okay, so that means you are going to get mercury and then with the 2 bromide. Okay, so bromine changing to I to bromide. All right, so let's pause the video now and complete 6c and 6d. Please resume the video again when you finish. All right, let's take a look at number 6. Hopefully you already finished. Chromium. Okay, so chemical formula of chromium would be, chemical symbol, right, would be Cr. And 3 plus tell us that this is going to contain 3 plus charge. Nitride. What is nitride? Nitride come from nitrogen, right? So that means in this case it would be N. Nitride come from nitrogen. So you are going to look up on the table. You will see that nitrogen is in group 5A, would have 3 minus. So therefore, in this case, already 1 to 1. So that means the chemical formula of this would be just CrN. Okay. Last one, lead. Right, so this is lead. This is part of the transition metal. And sulfur is going to be S2 minus, right, because it's in the same group as oxygen. But we have 2 of them. So therefore, in this case, we know that 2 of the sulfur that contain negative 2 add to lead, right, is need to equal to 0. If you solve for this, you are going to get the charge of lead come out to be positive 4. Okay, so that means the Roman numeral that we're going to specify would be positive 4. Okay, so it would be lead and then use Roman numeral 4 and then sulfur change to sulfide. Okay, so that's the practice for it. All right, number 7. Okay, so this one is going to associate with the polyatomic ions. So we need to use the list that's given on page 84 to help you with this. Calcium permanganate. So of course, if you're looking at permanganate, it would be this one right here. This is the permanganate. Is MnO4 minus. MnO4 minus. Okay, so if I go back here, we are going to, so permanganate is MnO4 minus, calcium is Ca2 plus. So you will see that we need 2 of these per 1 of these, right? So that's why you are going to use parentheses and then subscript 2 because we need 2 of these total, right? So that's why you need parentheses MnO4 subscript 2 because that is referred to as in the chemical formula. Okay. The next one, this one, iron. Is iron part of the main group element or is it part of the transition metal? The answer is part of the transition metal. Therefore, we need to specify the charge. How do you know that? Okay, so again, we are going to need to go to look at BRO3, right? BRO subscript 3. So BRO subscript 3 is bromate. Okay, so that's going to be the name of it. And the charge of bromate is -1. Okay, so I'm going to analyze this. So we know that bromate has -1 charge. And we know that there are 3 of them. Right, so we know that there are 3 of them, so we know 3 of them. We're gonna add this into iron. We don't know what is iron, but overall need to come out equal to 0, right? So we have iron right here. So if this is negative, right, the overall, since we have 3 of them, it would be -3. -3 add to what, right? Equal to 0. The answer is iron in this case would be +3, right? Because iron need to be +3 in order to add to this -3, so the overall equal to 0. So that means the Roman numeral for this would be iron 3 bromate. Okay, so it's come from that. All right, so what I would like you to do is go ahead, pause the video again, and try to complete 7C, D, and E, and resume the video when you finish. All right, let's take a look at your answer for 7C. Potassium is K, right? Hypoiodide, if you go back to this, hypoiodide is IO, right? So hypoiodide. So it would be IO. So therefore, in this case, it would be 1-to-1 because hypoiodide is -1, potassium is +1. Okay. Next one is barium dihydrogen phosphate. Okay, so barium. So let me actually see. Okay, so what do we need here? We need dihydrogen phosphate. Okay, so where is dihydrogen phosphate? Dihydrogen phosphate would be this one right here, right? So H2PO4 minus. Okay, so we know that this part right here is equal to H2PO4 minus. Barium is Ba. Barium is in group 2A, so barium would be Ba2 plus. Therefore, in this case, to have these to be balanced, you need 2 of this whole thing, right? You need 2 of this whole thing, right? So that way the overall will equal to 2 minus. So that means in this case, the way to write this would be Ba, right? 1 Ba per every 2 of H2PO4, right? And then to specify that are 2 of this whole thing, you are going to use parentheses and then write the 2 after the parentheses as a subscript. Okay, so it's just indicate that you need 2 of this whole thing. Last one, okay, so we have polyatomic ions for sure, right? NH4, that's ammonium. CO3 is carbonate, right? So that means the name of this would be ammonium carbonate. Okay, so things that I would like to, let me talk about this first before we move on. Thing that I would like you to notice about the polyatomic ions is that most of polyatomic ions would ending their name with the word ate or ite. You probably notice from here, right? Acetate, nitrate, chlorate, iodate, perbromate, right? It's ending with all the ate. Or another one is ite, right? Nitrite, chlorite, iodide, bromide, for example. Okay, so whenever that you see the name or you hear the name that ending with ate or ite, note that does have to come from this list of polyatomic ion. You need to come back to this list to help you write out the name or determine the charges. The only species that did not ending with ate would be ammonium. Okay, so that would be exception. Okay, ammonium, hydroxide, cyanide. So those are the 3 that is doesn't ending with ate. That is part of the polyatomic ions. And you are actually going to use those the most too when we talk about, especially with hydroxide, when we talk about acid base. Okay. So now, what about the difference between all of these 8 right here, right, and ite? So pretty much these are going to be different because they have different number of oxygen. note that the one that have more oxygen, so chlorate, okay, so chlorate would be the one that have, what do you call, like, most of them are containing 3 oxygen when it's ending with 8, right? So it's going to contain 3 oxygen, right? So for example, in this case, but it doesn't work with the sulfate and phosphate, by the way. So most of the time, that's what is referred to, okay? The perchlorate, it will tell you that it's going to have an extra oxygen. Chlorite, ending with "ite," it means it's going to have 1 less oxygen. Ending with having hypochlorite, it means that it's going to have 1 more less oxygen from the chlorite. Right? For example, in this case, perchlorate would have 1 more oxygen than chlorate. Okay, chlorate would have 1 more oxygen than chlorite. And then chloride would have 1 more oxygen than hypochlorite, and that would be the trend for this. Okay. All right, so the next thing I want to mention here, and this is really important because many students got confused. Okay, so for example, how do I differentiate between nitrogen, right, 3 minus, versus NO3 1 minus versus NO2 minus? The answer is you can tell about this by the number of the element, and also you can tell them by the name as well. Okay, so again, if the ions contain more than 2 elements, more than 1 element, right? Those are the polyatomic ions, and most of their name will ending with either 8 or "ite." Therefore, in this case, these 2 names gonna end up with either 8 or "ite." So this one have more oxygen, so this would be nitrate. This would be nitrite. Okay, the one that doesn't contain any oxygen is going to ending with "ide." So this would be nitride. Okay, so let me write that out. So this would be nitride. Okay, so this would be nitrate. This would be nitrite. Okay, so that's how you differentiate them. If it's ending with "ide," you know that that nonmetal contains just only 1 nonmetal. It doesn't contain oxygen. Whenever it contains oxygen, it's going to either ending with 8 or "ite. Okay, except ammonium, hydrogen, and cyanide. Okay, let me show you another one as an example. For example, if you have S2 minus versus SO4 2 minus versus SO3 2 minus, the name would be different, right? So this first one doesn't contain any oxygen, is going to ending with "ide. It would be sulfide. Okay, these 2 contain oxygen. One of them that has more oxygen would be sulfate. Okay, the another one that have 1 less oxygen would be sulfite. Okay, so the ending will tell you about whether it's going to contain oxygen or not. Okay, so this is very crucial. This is how people will be able to differentiate it. Okay. All right, last part of the practice is the hydrate ionic compound. So let's take a look at 8A and 8B. I would like you to pause the video and attempt these 2 problems and then check your answer again when you finish. All right, let's take a look at 8A, lithium nitrite monohydrate. Ooh, remember what I talked about? Whether it's ide, or 8. Nitrite mean, is this molecule contain oxygen? The answer is yes, right? So this nitrogen right here need to come with oxygen. I don't know how many, right? So what you need to do is go back to your list to find out what is the chemical formula of nitrite. Okay, so what we're going to do is I'm going to go ahead, list out one by one. Lithium is Li. Lithium is in group 1A. We know the charge for sure would be +1. Nitrite, if you look up the list of the polyatomic ions, it would be NO2 minus. We just look at that, right? We just look at that as this is nitride, this is nitrate, this is nitrite. Right, so we already look at that. So nitrite would be NO2 minus. Lithium 1 plus, NO2 1 minus. So they are going to need 1-to-1 ratio between these. So it's just going to be LiNO2. Monohydrate, mono mean 1. So that means you are going to have only 1 hydrate. Hydrate is water. So therefore you're going to get this dot to separate the two molecules, right? And then water would be at the end. Again, whenever that you see one molecule, they don't actually use number 1 because it's already implied that this is already one molecule of water. Okay, so you don't need to actually specify 1 in front of it. The next one is COPO4. Okay, so for sure, this is going to be one of the polyatomic ions. Okay, this polyatomic ion is called phosphate. Now, what about this one, CO? Okay, so CO, make sure that the second letter have to be lowercase because these two are not the same. Okay, so CO like this versus CO like this. This is cobalt, this is carbon and oxygen. They are not the same. They are not identical. Okay, so make sure that when you write it, you make sure that you make it clear to me, okay, because they are not the same. So in this case, this is cobalt. Okay, cobalt is part of the transition metal, so you will need to specify the charge with the Roman numeral. Okay, so what should be the charge of that? Okay, so that's what we're gonna determine. Because we want to determine the charge of cobalt, we need to know the charge of phosphate. If you look up the list of the polyatomic ion, you will see that the phosphate PO4 is come with 3 minus. Okay, note that this chemical formula here contains 2 phosphate, right? So it's contain 2 phosphate here. So that means what you are going to have is that these together, 2 phosphate, each phosphate is 3 minus, 2 of them would be -6, right? So that means in this case, the cobalt that we have, which contain 3 of them, so these 3 cobalt that we have, oops, I don't have space here, 3 cobalt that we have, oops, 3 cobalt that we have, we don't know what is the charge of this, right? So we don't know that. So, but it somehow have to come out equal to +6, right? Because overall equal to 0, right? So overall is need to equal to 0. So that means what should be the charge of this then? Well, what is it that multiplied to 3 that give you +6? The answer would be +2, right? So if how you determine, so if this is confusing to you the way that I write, what I highly recommend you to set up would be another form. Okay, so that is another form. You want to know cobalt, we have 3 cobalt. Okay, we don't know what is the charge of cobalt, so I'm going to list out 3 cobalt. Okay, you're gonna add this to the charge of phosphate. We have 2 phosphate, each phosphate is -3. Okay, set this up equal to 0, solve for that. If you solve for that, you are going to end up solving for cobalt, and cobalt gonna come out equal to +2 anyways. Either way, it's going to come out equal to the same charge, right? So in this case, the Roman numeral would be 2. Okay, so now what about number of water? So 8 would be octa. Okay, water would be hydrate, so it would be octahydrate at the end. All right, so here is the summary of everything for the naming and also writing chemical formula of the ionic compound. Please practice this more for the Newton homework. Okay, so you're gonna get a hang of this eventually.